Hi there, here we go with lesson 6.1. I see that it says 6.4 on there, but we're really just learning, whoops, we're really just learning 6.1 today. There, better. Okay, so get your notes packet out so you can follow along and take notes. I had wanted to show you this joke at Thanksgiving time and I just never did, so here's that. I thought it was funny. Okay, so today we are going to identify solutions of linear equations that have two variables. Those two variables are the x and the y. And then we are going to solve systems of linear equations by graphing. And I just lost my pen. Hang on just a second. Okay, I'm back. I had to find my pen. And so the words that you want to fill in are are solutions and graphing. And then there's the vocab that we're going to learn today, and here's where you'll fill in the definitions. So a system of linear equations is two equations and they both have the same two variables in them. So like it's two equations and both of them have x and both of them have y. And then the solution is two variables, or the solution to a system of linear equations with two variables is an ordered pair. So it'd be like, 3, 5 or 2, 1. We've been working with these ordered pairs. The first number is the x, second number is the y. And so it would mean that you can plug in 3 for x and 5 for y into both of those equations and both of them would turn out true. So let's check and see whether 5, 2, whether when x is 5 and y is 2, whether that makes both of these equations. So we have two equations and we know that they go together because they have this bracket on the sides. So let's see if 5, 2 makes both of these be correct. So if we plug in on this one, if we plug in 5 for x, so instead of x we put 5, and we plug in 2 for y, will that equal 0? Well, 2 times 5 is 10, divided by 5, that's 2, minus 2 equals 0. Is that true? 2 minus 2 is 0, and sure enough that equals 0. Okay, so for the top one, 5, 2 works. Now let's check the bottom one. 3 times 5 minus 2, let's see if that equals 13. Okay, 3 times 5 is 15 minus 2. 15 minus 2 is 13, and 13 equals 13. Okay, so that's good. So when x is 5 and y is 2, you can plug in 5 and 2 for these numbers, and both of these equations will turn out to be true. Remember how we used to solve just for x? Now this would be like if we had solved for x and y at the same time. And those are the numbers we can plug back in to make both of these true. So when you're checking your equations and they gave you your ordered pair, if you plug it into the first equation and it turns out that it's not true, then you wouldn't have to check the other one. All right, now let's try this one. Let's see if negative 2, 2. Let's see if that is a solution for both this and this. Can I plug in negative 2 for x and 2 for y and make both of these equations come out correctly? Okay, so instead of x I put negative 2 plus 3 times, and instead of y I put 2, equals 4. Negative, and let's do it up here. Negative 2 plus, and 3 times 2 is 6. Does that equal 4? Negative 2 plus 6, sure enough, that's 4, and 4 equals 4. So very good. So for the top equation, negative 2, 2 works. Let's try it on the bottom one. So we want to put in negative x, and negative, negative 2, plus y, so plus 2. Does that equal 2? Well, negative 2, that's the same as positive 2 because a negative and a negative make a positive. So is 2 plus 2 equal to 2? No, that's 4 is equal to 2. Well, no, 4 is not equal to 2, so it doesn't work. So this point is not a solution for both of the equations. It has to be a solution for both for it to be the solution for our ordered pair. So no, it's not a solution. All right, now it's your turn. So you plug in 2 for x and negative 1 for y. Plug it into the top one and then plug it into the bottom one and find out whether or not it's a solution for both of these equations. Pause the video and work that out. So, all solutions of a linear equation are on its graph. And so to find a solution of a system of linear equations, you just graph both the lines and find where they intersect, and that'll be your solution. So first you graph the top line, and you know how to graph a line, and then you graph the bottom line, and then you find out where do they intersect, okay, and then you get the coordinate of that point where they intersect, and that's your solution. There's your x, there's your y. So on this one, the point 2, 3 is where those two lines intersect. So you can plug in 2 for x and 3 for y, and it'll make both of these equations be true. That's a point that exists on both of those lines. And so we graph these, and sometimes when you're just graphing it and you're not using a calculator, it can be hard to tell where the lines intersect. So you can go back and check your answer to make sure that's right. So let's try it. Okay, first let's graph this line, y equals x. Okay, there's no slope in front of x, so if we don't see a number in front of x, we put a 1. And we don't see a y-intercept, so that's the same as plus 0. Okay, you remember that from the day that we learned transformations. All right, so this line. Our y-intercept is 0, so we put a dot right at 0. Okay, and then our slope is 1, so that's like 1 over 1, so we go up 1 and over 1, and we put a dot there. And then we got to connect the dots. You want to connect the dots as straight as you possibly can. You want to make a perfectly straight line because you want it to intersect just exactly right. Okay, so let's connect our dots as straight as we possibly can and extend it in both directions. Alright, so there's line 1. Now let's do the second line. We'll do the second line in blue. Okay, our y-intercept is negative 3, so we go down to negative 3. We put a dot. And our slope is negative 2. That's like negative 2 over 1. Okay, so from this dot we go down 2, 1, 2, and we go to the right 1, 1. And now we want to connect those dots just as straight as we possibly can. If you have a ruler, that'd be pretty awesome. Okay, so now we connect these dots. Extend your line in both directions. Super duper straight. Okay. Well, now it looks like these two lines intersect right here. And if I had to look, it looks like it's about at negative 1, negative 1. Okay, so it looks like, whoops. It looks like our coordinate for this intersection right here is negative 1, negative 1. Okay? Let's just double check because we're not quite sure that we got the intersection in just the right place. So let's plug it in. So here, instead of y, we can plug in negative 1 because this is xy. So negative 1 equals negative 1 plus 0. Okay? Well, negative 1 equals, and negative 1 plus 0 is negative 1. Yep. Negative 1 equals negative 1. So that's right. Good. Now let's check this one. Okay? Plug in negative 1 here for y equals, well, let me do it down here. Okay, so it's y equals negative 2x minus 3. So instead of y, we put negative 1 equals -2, and instead of x, let's plug in -1, minus 3. -2 times -1 is +2, then the minus 3. -1 equals 2 minus 3 is -1. -1 equals -1. That's right. So our intersection, or our solution, is at -1, -1. So that's our solution to our system of equations. That's what you can plug into both of these to make it be right. Try another one. Let's graph this line. Okay? So we'll graph this one in blue. So -1 is our y-intercept. And then our slope is -2 over 1. So we drop 2, and we go to the right one, and we put another dot. And we want to connect those lines super straight. Okay. And then let's do this other line in red. Our y-intercept is 5, so we go up to the 5. We put a dot there. And our slope is 1. So we go up 1 and to the right one, and we put another dot. And then we connect our dots as straight as we can. Kind of like that. Okay? And it looks like we get an intersection right here. Those two lines cross each other right there at this point. And that point is -2, 3. -2, 3 is our point. So now let's plug it in and see if that intersection is right. See if we really got this right. Okay, so y equals -2x minus 1. 3 equals -2 times -2 minus 1. 3 equals -2 times -2 is +4 minus 1. 4 minus 1 is 3. 3 equals 3. That's correct. Now let's check it on this one. Y equals x plus 5. So instead of y, we put 3 equals x. So -2 plus 5. -2 plus 5 is 3. 3 equals 3. So that's correct. So yes, our system of equations solution is x is -2 and y is 3. Or we just put it in ordered pair. -2, 3. Now it's your turn. You graph this line, then you graph that line, find out where they intersect, and then get the coordinate of the intersection, and then plug it back in here and here. Okay? And remember, this is 1/2 is your slope. You don't see a y-intercept, so that's like +0. See, you pause the video and try that and see if you can find a solution. Okay, now if you go to the second page of your notes, there are instructions for how to use your calculator, so you don't have to graph by hand anymore. You get to use your calculator, and that's pretty cool. Okay, so now let's try graphing with our calculator. Well, remember, in the calculator, everything has to say y equals when we graph something. So let's solve, before we put it in the calculator, let's solve this bottom equation for y. We want to get the y by itself. Okay? So that 2x has to move to the other side of the equal sign because we want y to be by itself. 2x is positive now, so we subtract 2x on both sides. And we get y equals 4 minus 2x. Okay, so now we have this one and we have this one. So get out your calculator. Okay. And so we hit, let's pretend that you open it up to the main screen. First we hit the y equals button. That's right here in the top left-hand corner. You hit your y equals button. Okay, then we type in the first line. So y equals is already written out for you, so you just got to type in that part right there. So if you want to put in the fraction 1/3, first you put a parentheses, and then you type the top number 1, then you hit the division sign, then you type the bottom number 3 because it's 1/3, then you close your parentheses, okay, type your x, that's right here, minus 3. Okay, so now we have 1/3 x minus 3, 1/3 x minus 3. Then you hit your bottom arrow, your down arrow, and now we can type in this equation, but we want to type it in this way, y equals 4 minus x. So they already have y equals written for us, so we just have to type in 4 minus 2x. 4 minus 2, then hit your x button, x. Okay, now we want to find the intersection. We want to calculate the intersection. So see, we have calc right here. That stands for calculate. And it's written in blue, so first we hit the blue second button, and then the trace button, because calculate's above that. Okay, what do we want to calculate? The intersection. So it's 5, so then we hit 5 for intersection. Okay, so now it's drawing out the lines, and now we just hit enter to get through these questions. Don't really worry about that. Enter, 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 so you hit enter 3 times, and then it puts the cursor right on top of the intersection, and it tells you that x is 3 and y is -2. So your solution then is 3, -2. Cool. Try another one. Okay, so we got to do this one. They both have to be solved for y. So that one's already solved for y, no big deal. Let's solve this one for y. Okay, we want the y to be by itself on the left side of the equal sign. So that 2x has to move over. It moves, it's positive now, so it moves by subtracting it on both sides. So y equals 1 minus 2x. So now we have two line equations, that one, that one. So let's get into our calculator. Remember, we want to go to y equals, so we can type in our two lines, clear out everything that's in there, then type in your first one, y equals, that's already written, x minus 2. X minus 2. Hit the down button. Now let's type in this equation, y equals 1 minus 2x. 1 minus 2x. Okay? Now we want to calculate the intersection, so the blue button and then the trace, that way we can get calculate. What do we want to calculate? The intersection. So you hit 5. Let it draw its lines. Now we hit enter 3 times. 1, 2, 3. There it is. The cursor is blinking right where those two lines intersect. And it tells us that they intersect at 1, -1. X is 1, y is -1. So our solution there is 1, comma, -1. That's the x, and that's the y. Okay? Now you try. So solve this for y, and then solve that for y, and then plug them in your calculator, and you have the instructions for your calculator right in your notes. Okay, now here's a problem. Ren and Jenny are reading the same book. Ren is on page 14, and she reads 2 pages every night. Jenny's on page 6, and she reads 3 pages every night. And after how many nights will they have read the same number of pages, and how many pages will that be? Okay? So we need to think about this. First, we need to think about what's the independent variable and what's the dependent variable. Okay? Well, independent is something that would happen regardless of the other thing happen. So independent would be the number of nights. Okay? Nights would pass regardless of whether she reads her book or not. Okay, so the independent is the number of nights. And then the dependent, once you know how many nights went by, what can you figure out? Well, you can figure out how many pages they read. Okay, so pages, how many pages they read, depends on how many nights went by. Independent, is that the X or is that the Y? It's the X. Dependent, that's the Y. Okay, now we can write our formula. So it's two different ones. First we've got run. Okay, so let's write our equation out for Ren. Well, she's on page 14 and she reads 2 pages every night. So the number of pages she reads, or the Y variable, equals, she already read 14 pages, plus 2 every night. So 2 times the number of nights, that's X. And then let's do Jenny. Okay, well, she started on page 6, the number of pages that she's read. Y equals, the number of pages is Y. 6 to start, and then 3 pages every night. 3 times every night. Nights is X. Okay, so we have 2 equations, and those are related to each other. And after how many nights will they have read the same exact number of pages? And how many pages will that be? Okay, so let's find out what numbers for Y and X can we plug into both of these equations to make it true. I don't feel like doing that out by hand, so let's get out our calculator. Okay? So we go Y equals, clear whatever's in there. Okay, our first equation is 14 plus 2x. Okay, and our second equation is 6 plus 3x. So down on the second line, 6 plus 3x. Calculate the intersection, so second calc, intersection, that's choice number 5, so we hit 5. Here's our 2 lines. Okay, you can't see the intersection. That's okay. All right, we just need to go through the question. So we hit enter 3 times. 1, 2, 3. And it tells us that the intersection is at x is 8 and y is 30. X is 8, y is 30. So it's 8, 30. Okay, so X stands for the number of nights, so she reads for 8 nights. Okay, that's the nights. And they get through 30 is Y, that's pages. So that's the number of pages. So after 8 nights, they've both read 30 pages. If 2 linear equations in a system have the same exact slope, then they're parallel. And remember, parallel lines never intersect, so they wouldn't have a solution. So if you had a graph and you had 2 parallel lines, let's say one goes like that and one goes like that, well, they're never ever going to intersect, so parallel lines have no solution. Okay? What if you graph 2 lines and it turns out they're exactly the same line? So basically you graph the same equation twice. Okay, so here's a graph, and you do the first line, and then you do the second line, and it happens to be the same exact line. Okay, well, that means that they share every single point. Okay, so there's a million different kinds of x's you can put in and a million different kinds of y's you can put in, and it would be the same point for each line. Okay, so then we say that there's infinite solutions. Infinite. You could put anything in and you'd get out a solution. And then we already talked about how lines that intersect, if they have just one intersection, then it's one solution. All right, well, I think we're done. Your homework is that worksheet that's on the last 2 pages of your notes. So thanks for playing along. I hope you had fun with the calculator today. I like that calculator. Bye.